So from class today, we want to list the transformations of the parent function. We always look at where the vertex is and where the origin is to help us with our transformations. So this one has been shifted 1, 2, 3, 4, 5 units to the left. So we'll write 5 units left. It has been shifted 2 units down, so there's 1, 2 units down. And my parent functions are always like this, pointing up. We'll go through 1, 1, 2, 2. They're always pointing up, so I can tell that this has also been reflected against the x-axis. So reflected in x-axis. Good. So domain. Domain is talking about what are the biggest and the smallest x numbers I could have. So the smallest x numbers, -5, -6, -7, -8, -9. I still have a graph down here, and as a matter of fact, I'm going to continue having a graph. It's going to keep on going down, so I'm going to keep on having smaller and smaller x numbers. I'm going to have smaller and smaller x numbers all the way out to -infinity. There's my domain, and I'm ready to get the biggest x numbers, so -4, -3, -2, I'm getting bigger. 1, 2, 3, 4, 5, I'm starting to get bigger numbers, and this is going to keep on going down. So as the graph keeps on going, I'm going to have more x values, 5, 6, 7, 8, 9, 10, 11, all the way up to +infinity. My range, I'm down here again, I'm looking at the smallest y values now. So -3, -4, -5, -6, I'm getting smaller, -7, -8, 9, 10, I'm going to have them all the way down. They're going to keep on going to -infinity. On the range side, and the biggest possible y value that I could have, I'm going to come up here. The biggest possible y value that I see is actually at -2. I don't have a graph at -1, I don't have a graph at 0, but I do have one down here at -2. So that's the biggest y value that you can have. Where is the function increasing? So my function is increasing. If I'm reading from left to right, I'm increasing here. In other words, I have a positive slope all the way to -5. So my positive slope happens from -infinity to -5. That's where I'm increasing. And then from -5 all the way to +infinity, right, I've got a decreasing. I've got a negative slope here. So I'm going to be decreasing from -5 all the way to +infinity. So from -5 to +infinity, I am decreasing. To write the equation of the graph, we just need our transformations, and we need the parent function. The parent function is y equals the absolute value of x. We've been shifted 5 units left. So 5 units left is a +5 inside of the grouping. 2 units down is a -2 outside of the grouping. And a reflection in the x-axis is a negative sign on the outside of the grouping in the front. Alright. So we're now looking at our cubic function. I know this is a cubic because it has 1, 2, 3 turns. So there are 3 turns here. This is y equals x cubed is our parent function. It's a cubic. I can see it has a bounce right here and a cross right here. So in my bounces, this is going to be a double root. In other words, I'll have 2 roots at x equals -1, and then I'll have 1 root at x equals 3. So let's take a look at what that would look like over here mathematically. Where is the function increasing? The function is increasing from here at -infinity, and I'm over on the x-axis. I'm talking about the x-axis, -infinity, all the way up on the x-axis to -1. That's when I'm increasing, from -infinity to -1. I'm decreasing here to about 1.5. and then I'm increasing again over on this interval to all the way up to positive infinity. So I am increasing from negative infinity to negative 1, and I'm also increasing from 1.5 on the x-axis, from 1.5 all the way up to positive infinity. Where am I decreasing? I am decreasing in this interval right here. You see how the graph is going down? I'm decreasing from the x value of negative 1 to the x value of 1.5. So all in this interval right here, this is where the function is decreasing, from negative 1 to positive 1.5. Talking about end behavior is as x moves to positive infinity, what does y do? And then as x moves to negative infinity, what does y do? Where does the y function go? Okay. So as x goes to positive infinity, we're out here, our x numbers are getting bigger and bigger and bigger, and as x gets bigger and bigger, what does y do? Y actually also gets bigger and bigger and bigger. We're going to go to 1, 2, 3, 4, 5, 6, 7, all the way up to positive infinity. So as x goes to positive infinity, y goes to positive infinity. Now we're going to talk about x going to negative infinity. So as x comes out here on this side of the graph to negative infinity, what does y do? Well, negative 4, negative 5, negative 6, as these x numbers get smaller and smaller, I'm looking at my graph and it's getting smaller and smaller as well. I've got negative 9, probably negative 10, 11, 12, 13, 14, so all the way down there to negative infinity. Okay. The real solutions of the function are what we already identified, right? The solutions are where the graph crosses or touches the x-axis. So here's one at x equals negative 1, and another solution here at x equals 3. These are roots, solutions, zeros. All of these mean the same thing in this context. So for number 5, it says write a function for the graph in factored form. That's nice for us because we can just take these roots and make them into factors. So x plus 1 times x minus 3. And I immediately notice something off because I have 2 factors, but I'm working with a cubic. So I need to have 3 of them. Well, this bounce right here, the bounce, how I write that is going to be with a squared exponent here. So this is the bounce, and then I have a cross at x minus 3. So there's the cross at x minus 3. Okay. So here we go. We have an x squared times x is now x cubed, and that's the cubic that we're looking for. So that's all 3 factors, and they told us to name this function f of x. So we're going to name it f of x. Maximums and minimums are just those points that we used for increasing and decreasing in number 1 and number 2 up here. So our maximum, local maximum, happens at this coordinate point, negative 1, 0. The local minimum, the minimum point happens down here at 1.5, negative 9.5 at that coordinate point. And then they want us to solve for where does the function happen when y is negative 6. So we're going to come down here to where y is negative 6. And I actually see now 3 solutions for that. The function crosses here at negative 6, here at negative 6, and here at negative 6. So we're going to list those 3 coordinate points. This first one is negative 2, negative 6. The next one is at 0.5, negative 6. And then the last one here happens at 2.5, negative 6. Okay. Now let's talk about transformations.